All right. So where we are right now, I want you to see the point where you can get your data. And I'm gonna walk through this because I want everybody to understand what we're picking and why we're picking this. So you've heard Dr. Juan talk about ENCODE several times. It's an encyclopedia of DNA elements. And the first place that we're gonna go is right at the top to data. So what you wanna do is click on the data tab and you'll get a drop-down menu. The first thing that comes up is called matrix. Click on that. Now this gives you an understanding and an idea of the types of data from organism, tissue type, cell type, analysis type, whether it's ChIP-seq, whether it's DNA-seq, all right here. Okay, and what we're going to focus on for this set of homework is mus musculus, so we're going to be doing mouse. So the next thing you want to do is click on mus musculus. Now there's a group out of the University of California at San Diego, a researcher named Bing Ren, who's really done some amazing ChIP-seq work, and so we're going to use his research data, and it's in the brain. Now, one issue that you're going to see, if I tell you to click on brain, there's midbrain, forebrain, hindbrain. Don't do any of those. Click on C43 more, and as you'll come down the page, you'll see brain itself right here. The first column is ChIP-seq, so click on that number 9. So we went to ENCODE, the project page, and it's all right here for you. If I'm moving a little fast, I apologize, but I just want you to see everything that's happening. We went to the ENCODE page. Up on top, we clicked on data. A drop-down menu came down, it's called matrix. Click on matrix, and we got the whole listing of all the data that's listed at ENCODE. The next thing that we did is we went to organism on the left-hand side and clicked on mus musculus, which is mouse. As soon as that came up, we went to the tissue section, which is the red column right here. Hit 43 more because there are multiple sets of data, and we came down to brain. I did this on purpose, guys. I did this way so you could visually see that when I put on the paper brain, I specifically meant brain. I know it's very confusing because there are multiple sections of brain that are on there, but actually just come down to the part that says brain. So we're going to click on the 9 right next to brain. This is where you're going to get your data. Okay, there are 2 data sets that Dr. Juan and I have decided that you need to work with. One of them obviously is a control, and one of them obviously is a treatment. So what we're going to see here, it's called CTCF, right here. The target is CTCF. Okay. If we click on that, we're going to go and see some files that are housed there. Now, if you scroll down the page, right toward the middle, you'll see a segment called File Details. Now, this is right where you want to be. Okay, so you went from matrix, you went from data to matrix, to organism type, to tissue type. Now we're in the target, and these 2 files right here, you're going to have to download. And what I recommend that you do is to download them directly into your working directory in Karst. Okay, remember, the less you move files, the better off they are. If you take a file and put it in a Windows environment, or Windows environment back into a Linux environment, files can get mutated, changed, things can get cut off. Use your wget command in Karst. Right-click on this tab right here. And what that's going to do, it'll give you the opportunity to copy the address. So when you're in Karst, you can put wget, put in your address, and download the file. Okay, do that for 2 FASTQ files for CTCF, and then we're going to do the same thing for control. And I want you to see everything here is extremely straightforward. There should be absolutely little to no confusion. It's called control. So we'll do the same thing again. Click on control, the page will come up. We'll go to File Details. There's your FASTQs. So you're going to download 4 FASTQs, 2 for CTCF, which is your treatment, or your antibody, your target, and 2 for control. Part of your homework assignment is going to be, I would really like to see you do 2 things when you get into Max 2. I would like to see you call peaks for CTCF versus control, and then just CTCF by itself. Okay, because I want you to get a hands-on understanding of the differences that happen when you have a control and when you don't. Control is a very important step in calling these peaks. Everybody feel okay about using encode? Right? So it's all on that sheet, step by step. Just again, I hate to reiterate this because I know you guys are really sharp, but if I'm not saying things clearly, I want to go slowly and make sure everyone feels comfortable. Pull up the encode project page. You'll go to the data tab. A drop-down menu will come up. You'll hit matrix. On your left-hand side, you'll see an organism. Select mus musculus. Then you'll select tissue type. You'll expand the tissue type and go directly to brain. And then the 2 samples that you want are CTCF and control. Okay? And just directly download using wget or whatever avenue you'd like to do. apt-get, whatever you like. I use wget because it's straightforward and simple, and it just always works. But whatever you like, just get those files into your working directory, and then you'll be all set to go. And remember, there's 2 things that I really want you to do, with control and without control. And I want you to compare the peaks and see what you get. But I also want you to look at the differences between broad and narrow. So there are 4 things you're going to have to do, okay? We'll get there. It'll be a little bit easier. Any questions on where the data is and how to get the data that you need? Are we good here? Because if not, I'll just start moving on into the software programs that you guys need. Good? Okay. For me, the most obvious place to start is your Bowtie 2 manual. And again, this has been loaded. This is a document that's been loaded for you guys. It's been sent to you, but it's also online. You've worked with BWA. You've now worked with the star aligner, and now you're going to work with your 3rd, which is Bowtie 2. The way the description on the manual goes, the reason for Bowtie 2 is an ultra-fast memory-efficient tool for aligning sequencing reads to long reference reads. It works completely different than the other aligners, but it uses some of the same components that you've seen before. This one is based on the Burroughs-Wheeler transformation, but it's an updated version of it called the FM index. Okay, there was another paper that came out a couple of years later that proposed another algorithm for how to condense this genomic information and make it so you can work with it very well. You'll find it to be very fast. It's much faster than BWA, and it's different than STAR, but I think the speed is really comparable to STAR. One thing you're going to have to do, and you're going to see this, there's a command that we're going to use, and I want to come down to it because this is going to make everything, you'll see the differences in how this works. When you worked with BWA, you had to have that reference genome FA file. Do you remember that? You had the 2-bit file, you converted it to an FA. Well, this is going to have an index file, but it's going to be a set of 6 files. And the reason for that is it breaks the genome up into smaller pieces, and then it actually compresses them and improves the speed for alignment. Where it went nucleotide by nucleotide for BWA, it was long and it churned. I think you're going to see this is much different. Let's get down to the usage. Here's our command. Right here at usage, you'll see Bowtie 2. So what you need to do when you're in Karst, first step is get your FASTQ files. Okay, let's say you have those. What you may want to do in Karst is create a subdirectory for your indexes. And I'll explain why in a moment. Okay, because this command is going to refer to those indexes. and it gave me fits while I was trying to do this. And I want you guys to have a nice, smooth transition. So I'll explain some of the issues that came up when I was working with Bowtie 2, because I went several ways to do this index. But what you'll see here is the program name, step 1. Now, the convenient part for you is it's loaded into Karst already. So all you have to do is to find it, is type module space AV, pull up the list of the modules that are available in Karst, go to the Karst Life Sciences section, and you'll find Bowtie 2/2.1.0. That's their default version of Bowtie 2. It works really well, and it's really fast. Module load that, okay? Now you've got your FASTQs. Now you've got your program loaded into Karst. So when you type Bowtie 2, that tells it what program you're going to start with. Then you see right next to it a thing called options. The default on this, quite simply, and I'll share that with you. It's all in this document. And the reason I'm talking you through everything is I currently don't have a shell on this computer, or else I would type the commands and run them for you. If you want, you're welcome to come by my office and I'll run all the commands for you to show you how they work. I just don't have a shell right now. So the command, the default command for Bowtie 2 will be Bowtie 2 dash lowercase k 4 dash capital X 2000 dash local dash P9 dash X, and then the FASTQ files. Your index comes, then it's -1, your first FASTQ, -2, your second FASTQ, and then -S for your output. And I'm going to tell you what every bit of that means, okay? Because when you see this paper, if you guys pull up Canvas and you see this paper, the command's right there under Bowtie. The K4, so Bowtie 2-K4, it's the number of valid distinct reads or alignments that Bowtie 2 will search for, and those are all based on the alignment score with a cutoff. The dash capital X 2000 stands for the maximum number of reads that Bowtie is going to use. It's part of what makes it much faster and much more efficient. Where BWA will just churn and churn and churn and work its way through all of the reads, the maximum reads that Bowtie 2 is going to take is set at 2000. You can change that, you can lower that, but 2000 is the maximal cutoff. Now, when you type in something called --local, have you guys noticed anything about this aligner so far that you haven't seen that you used before with BWA? What were the steps before you used BWA? You went through FastQC and then trim galore. You don't see trimming, right? So what this local command does is it's called a soft clipping or a soft trimming. It'll shave a few bases off here and there to improve alignments. So if it takes off 3 on one end, but it makes a better alignment out of it, it actually makes it run more efficiently. Then the number P9, it's number of threads. A small x refers to the index. This is the next thing that I'm going to teach you on the BW2 page. Indexes are really critical, and I built a couple of them for you, and trust me, you're going to want to do this the way Dr. Lou Remick recommended to me. By the way, Dr. Sheng Lu, you're amazing. I thank you for all of your help this week. If you guys have not met Dr. Sheng Lu, please meet him. He is amazing. Then you're going to see a -1, -2. That's just in reference to the FASTQ files. Then -S tells it to write the SAM file. You name the SAM file. You can put out.sam, you can put control.sam. I always call it whatever the sample is that I'm working with. This way I'm never confused about what sample I have. So for example, on the first one, I would call it control.sam, okay? Now, let's talk about that index. Remember, when we ran BWA, we had one reference file. It was that HG19 2-bit that we switched over to an FA. You're going to get 6 files when you download this. The reason for that is it breaks the genome up into 6 different pieces, compresses and aligns. It's much, much faster and much more efficient. Now, at the top here, on the right-hand side, you're going to see something called indexes. They're right here. So since we're working with mouse, if we were working with human, we would want an HG38, which is on here somewhere. I saw it the other day. But right now, there it is, GRCH38. You want MM10, okay? That is the latest version of the mouse. It's also called GRCM38. So MM10 or GRCM38. It's the most update alignment mouse reference genome available, okay? Now, the reason that we're doing that is Dr. Bing Ren, when he did all of the FASTQs, everything was referred to against MM10. If you use MM9 or MM8, what you're going to find is the alignments won't completely match up. You're going to have some false discovery and some ambiguous alignments. So please use MM10. All you have to do, again, is click wget right here on your MM10. And there are two links right there, mus musculus and UCSC, but they give you the same link, okay? You can put your cursor on either one and it'll give you the same link. Copy the address, bring it into your browser. This is where I was telling you may want to create a subdirectory. The reason for that is simply this. As you write your code, it's going to look for a certain type of name. And in the book here, in the manual for this, it calls it a BT2-index. Now be very careful with your naming conventions. Okay, it is extremely, extremely specific. Name your subdirectory whatever you want to name it. But what you will see at the end of these files, because it's bowtie2, you will see, it will say perhaps MM10. Remember, there's 6 files, .1, .2, .3, .4, and then 2 revision files, 1 revision, 2 revision. .bt2. When you create that index and bring it into your working directory, it has to be able to find your index. I named them using that BT2 part, the .bt2. It doesn't want any of that. What it wants is the part up until the .1. So if you call it MM10, if you call it BT2, whatever you call it, do not put anything after it, okay? So your index naming convention will either come back with one of two things. It's going to say, could not find an index, and you're sitting there looking at your directory going, it's there, I'm looking at it. It's all based on whether or not you have named your path to that index properly. So in other words, if you name it mm10.bt2, it's got a .bt2, it won't find it. It'll just keep telling you, could not locate index files. So be very, very careful. On the human side, I think it calls it genome. On the mouse side, I think it calls it MM10. So little subtleties, just watch how you finish naming your index and your path to it. So a couple other things about the index files. You don't have to take their index files. Okay, there's an option in here called bowtie2. It's called BT2-build. Do you remember when some of you guys had to go back and get that 2-bit file? There were also chromosome GZ files there. You can download a chromosome GZ file and you can build your own index. It'll take every single one of those chromosome files. And for a mouse, there are 19 autosomes and 2 sex chromosomes. It'll take every one of those chromosomes and build an index, okay? You can do that. You're welcome to it. I did that this week. I used a couple of different ways. I used it from NCBI. I used it from UCSC. It takes a while. My concern is that some of you have faced wall time in the past, and I'm afraid you'll time out. I don't want you to get halfway through. I don't want you to get, say, 15 chromosomes in and it quits. So take your time with it, but be aware, if you do build for your own project here, there may be wall issues. So you can download these directly. I highly recommend that. They're already done for you. Or you can do it yourself. Now I'll tell you the outcome when you build your own. You get 6 files, just like those. So you can get those 6 or you can make your 6. However you want to do it, it's up to you. BT2 builds 6 files. These have 6 files. It's up to you. Whatever amount of discovery you want to do, I encourage it. Just be aware that there may be wall time issues. If you want to get around those, just take the indexes that are already prepared for you. Any questions so far about BT2, Bowtie 2? The reason I call it BT2 is because a lot of the things that come up in it say BT2. So remember, what you're going to do in step 1 is download your FASTQ files. Then you're going to module load Bowtie 2. Then you're going to go ahead and download your indexes. It comes as a zip. All you have to do is unzip it in your subdirectory. You have your indexes. Then start building your command. And the usage command is literally given to you right in the middle of the Bowtie 2 page under a section called usage. Any questions so far? Now, those are default settings. Okay, what I've just told you there about Bowtie 2, K4, X2000, P9, local, those are all default settings and they work beautifully. They really generate a great SAM. You can add more, you can change more, you can take things out. What changes is computation time, right? So how efficiently and how fast you move through things. If you want to change the number of reads, you can change that, okay? And there are many, many, many more things that you can do. Again, there's an entire manual written on one code. So one line of code, many options that you can add and change. I encourage you to study this program because it's a great aligner, and ChipSeq is becoming so commonly used, you may want to get familiar with Bowtie 2. Okay, but be very careful when you build your indexes. Your naming conventions and your paths will make it a wonderful experience or a frustrating experience. So just be very, very careful. Don't add the extensions onto the names of your indexes. If that doesn't make sense, when you guys get a chance to sit and look at this sheet, study how it's written, and write me emails, because I've operated all of this software. I've got all these files for you. You can come to the office and look at it and I'll show them to you. I'll do them with you. Okay? But be very, very careful with how you handle the indexes. Any more questions on Bowtie 2? Yes, ma'am.
MM10 is when you unzip it, it's going to have 6 files.
Correct.
Right?
Correct.
So in the code, are you given the path to the MM10?
Nope. So wait, in the code, are you giving the path to the MM10? Yes. Yes. So what you're going to do is let me slide right back down, and it'll make it much more sensible. It'll make this part of the conversation much more sensible. So it's the path to that index, because the index itself is really considered all 6 files. Okay.
So you don't have to list all of them.
You do not. This is why I recommend you making that subdirectory and calling it BT2 index or whatever name you like. Okay. Don't use the names I use. Use the names that mean something to you. I'm a really simple, straightforward person. I call it Bowtie 2 index. Put that zip file in there, unzip it, you have all 6 files right in there in your path. So your present working directory where that's at, right? Whether it's the n/cars/whatever, or if it's gpfs/home/ however your directory is laid out. At the end of it, you'll put your BT2-index. At the end of that, /MM10. Now the reason for that is it's got to go in and look for the front part of that name. It's looking for 6 files because it knows it's an index, because you're going to put a small -x in front of it that says there's a Bowtie 2 index here and here's the path to it. But don't go past that first dot, because then it starts getting into that extension and it'll tell you it can't find it. So just small x, dash small x, path to it, slash name of the directory, slash name of the files, mm10. I didn't change the names for mm10. When you unzip the mm10 zip, it's literally, it says mm10.1.bt2, mm10.2.bt2, all the way down to mm2.2.rev.bt2. But don't go past any of the dots because it literally will tell you there's no index. That's how particular this thing is. So does that help? Does that make sense for how to write that index? Once you knock that step out, this thing runs like a piece of cake. I mean, you'll be amazed. Do you guys remember how long it took you to go through the alignment process with BWA? It was about 45 minutes, an hour, maybe a little longer. When I did the control FASTQs to the SAM, I was done 7 minutes. I mean, it's that quick. It's really efficient. It's because of the way it breaks down that reference file into those indexes and compresses everything. So the hardest part is the index. After that, it's a home run, guys. Bowtie 2 is great. Any more questions on Bowtie 2? Anything at all? And like I said, I don't have a shell where I'd be running this in front of you. My office is on the 5th floor of this building. I welcome every one of you to come sit with me in the office. We'll run this command. I'll show you how quick it runs, and I'll show you how to get through this homework. Because in my opinion, you need to understand ChipSeek. You need to see the results that you get back, but you also have a final coming up. You have a project coming up. You have other classes. I want this to be a very efficient, very enjoyable homework assignment for you. That's why you have one control and you have one treatment, okay? I think you will see the intelligence of how these programs are written when you guys sit with them. They're fabulous, wonderful programs. But I welcome every one of you to come to the office. I'd love to work with you. So don't be frustrated. And let me put it this way. If you're doing this homework and it's taking you 5 hours, let's chat, okay? So that's Bowtie 2. Let's go to SAM tools. Now, do you guys remember the output of the aligner? What file should we be expecting? What's our output? A SAM file. Absolutely right. You're gonna take those 2 FASTQ files for control and make one SAM for control. You're going to take those 2 CTCF treatment files and make one SAM for CTCF. Those are the 2 things that we're going to move on with and turn into BAMs. You're going to like SAM tools. Let's do some documentation. Let us see. This is how straightforward SAM is. Once you've generated, you've done the hardest part of all, okay? You got your index and you made your SAM. That's the hardest part. After this, again, I'm giving you simple default codes. You can get as complicated as you want to get, okay? There are many, many options in each of these packages. I'm gonna give you the most direct default statements to generate your peaks, okay? I don't think there's a thing wrong with experimenting with these programs. To convert this, don't want to download it. Let's do SAM tool view. There we go. Now, top one. Where did my little guy go? Can y'all see that? I don't think you can. Is that better? Okay, SAM tools view. All you're gonna do here, this is a default on it. You're gonna, again, this is loaded into Karst, okay? All you have to do is module load, SAM tools / 1.3.1, enter, it'll tell you that it's loaded. Then you have your two SAMs, okay? You're gonna type SAM tools, put a space, you're gonna type view. The whole point is to convert this from SAM to BAM. Now there's a couple ways to go on this, okay? The B, these are options. The ones that I'm gonna give you are very direct. B tells us it's a BAM file format. The T, that's a timing thing. You don't even need this part. You can put it in there if you want. So we can do SAM tools view -B -S. The reason I tell you -S is because it takes all SAM formats. There are multiple versions of SAM. If it's written from an older SAM, it'll convert it and it will actually let you align it. Then you want to put your BAM file. You want to tell it that you want to do align.sam or control.sam. Then you can put an arrow, right? A greater than symbol, control.bam, enter. It'll make it, it'll convert SAM to BAM. So SAM tools, view, -B, S, control.sam, greater than symbol, control.bam. When I made them, it took 4 minutes to convert. Okay, pretty quick. Do you remember anything specific about BAMs and SAMs?
BAMs are smaller.
BAMs are a lot smaller. So the reason is because it's binary. So SAMs are all text. They're typically large, but the binary version of it's much smaller. It's not readable by a human being unless you happen to be a computer. But truthfully, do not be alarmed at all when you look at the size of your BAM file and it doesn't match the SAM. It should be and will be much smaller. Okay, it'll still be a large file, but it'll be much smaller than the SAM that you generated from the aligner. Okay, so this is straightforward and simple to use. All you have to do, download your module, type in SAM tools space view -B S, your SAM file, greater than symbol, the name of your BAM that you want. I always go with whatever the sample is, so control or CTCF, then I can just make my comparisons. So you're 2/3 of the way done in about 10 minutes, 12 minutes, okay? These are really efficient programs. They work really well. That's how hard it is to use SAM tools. Any questions? And literally, it's right here. Everything you need is on that document that I loaded for you guys. It's both in the uploads where all the files are, and it's also in your mailbox. So, and I'm sitting in my office waiting for you. So whatever you want to do, we're going to get you through this. How do we feel about SAM tools? Good to go? Ready to move on? Let's go have some fun with Max. I wish I had a shell. I could do this for you. Now I'm just going to show you the code. Now, I'm going to warn you, there's a module loaded into Karst. It's max.1.4.2. Okay, it is an older version of Max. Now, if you try the commands from Max 2, it'll tell you that command couldn't be found. You have two different versions of a program. Okay, this is the one that's going to take your BAM and make your peak calls. Okay, you got to have a control if you want to be able to talk about the differences that are happening within treatment compared to control. But again, I also want you to just run broad and narrow on treatment alone. Okay, I want you to see why there's a control. You'll see a vast difference within the peaks. So let's go down and find what we need here. Max 2 itself currently is not loaded into Karst, so you have to go get it. So you can wget it, and you're going to get a zip file. You'll unzip that, but it's not installed. Okay? There's going to be an installation on it, and this will save you guys a lot of frustration. what you want to do to be able to, it comes with a lot of Python files when you unpack it. Okay, so I believe the manual on it calls for at least Python 2.7.2. Okay, anything earlier than that, it doesn't meet the requirements for the pip install. You're welcome to go past that if you want to go 2.7.3 or 3.3.0 or 3.5.0. You're welcome to do that. You may run into an issue with pip though, because when you get into Python 3, I think it begins calling for pip 3. So you may get some messages. The program itself calls for a default of Python 2.7.2. So stay 2.7.2 or 2.7.3. Either one of those and pip should work just fine. So all you have to do your wget, get your program in there, unzip it, and then module load Python, either 2.7.2 or 2.7.3. And then you'll do, let's see if we can, pip install. Yep, I believe I passed it. Right here. Here's your code. Pip install max2. And at that point, you'll have an executable program. Okay? Now, if you don't, I don't know. It's probably a little more forgiving for faculty and postdocs. I don't know student-wise if you'll have any issues with downloading and installing programs. If so, just check with the IT person from your department or from your lab or however it works, because it may come down to a sudo or a root issue. I believe it should not. It should work just fine. But if you do have any problems, it's going to be at that step. Max is pretty straightforward and pretty friendly, pretty amazing. So let's talk about any questions on installation, downloading, or getting Max 2. Everybody feel good? You okay? Great. Let's go look at how to run it. So let me make this bigger for y'all. So I ran this today, and it works really efficiently and smoothly. I don't think you run into any problems with the execution of this program. So basically, all of your options for each of the program that I'm asking you guys to run default-wise are here and explained. Okay, so open up this document, keep it to the side. If the code gets confusing for you, I've written the options here, and don't be afraid to pull up the manual, guys. Again, I'm giving you default instructions to run a basic program. Don't be afraid to explore. Go ahead and investigate what these programs can do for you as you move forward. So now you've heard narrow and broad peak calling, right? So if you're going to call narrow, it's what the program calls regular. So you will not do a module load max 2, right? Because you've already got it in your program. You've already got it installed. So call it max 2, call peak. So you're telling the program that you're going to use certain files and you want it to call peaks. -T is treatment. Okay, so that's going to be your CTCF. That's going to be your treatment file. That BAM that you just converted from SAM, you're going to put right here. -C is your control file. Okay. Now -F BAM, you guys have used this before. So do you remember when you used FastQC? You had to tell it -F FastQ. What's the exact same thing here? You're just going to tell it that it's a BAM. All that means is file type. -F file type. -G is what genome you're going to run. And so here, instead of HS, what do you guys think you're going to put? MM, home run. N is the name of the file that you're going to generate. Call it what you like. Like today, what I called it was CTCF peaks. Okay? It doesn't have to be test. If you want to call it test, you feel free to call it test. It's your directory. I mean, I want you guys happy. The -B, I always forget -B. Oh, that's right. Yes, this is great. So it creates bed files with graphs and different things that you can do downstream. You can also ask for some logarithm things in there. It can store some of the data that comes off with it. You can also do further false discovery rate testing with it, with Benjamini-Hochberg at that step, okay, when you're making those bed graph files. So there's a lot of options. Don't leave out your dash capital B. It's a very, very important step as you move forward. The last part of it, your dash Q, that's going to be where you're calling your false discovery rate, okay? I think the manual, if I remember correctly, said the default is 0.05, but for much more stringency, I think 0.01 is what's standard today. Is that not correct, Dr. Wan, that 0.01 is the standard? It's very stringent because you want these peaks to be specific. You're not looking for false discovery, okay? You want actual discovery. And so when you run this, remember, I want you to do this two ways. I want you to run treatment and control together for narrow. And then I want you to run treatment by itself. And then I want you to run the broad version of it, same way, okay? Treatment and control, and then just treatment. Now, a difference that you see on the broad range here, okay? Same start, max, call peak, treatment file, control file. Here we have broad. You're telling it that you want a broad range call on this. Your genome will be because it's mouse. And even in the manual, it will give you the size of the genome, because when it does some of this bed graph formation, it actually does a calculation where it uses read lengths and the genome size itself to make corrections for some of these calls and some of the peaks. So that's critical that it's there. The broad cutoff here at the end at 0.1, according to the manual, guys, says cutoff for broad region. This won't be an active flag unless you actually put it there. Its default is 0.01. So again, you have a little different range on this, okay? Do you have any questions about where to get Max2, how to install Max2, or any of these commands? It'll be very, very, Travis, what's your question?
So I just tried to install Max2.
Yep.
We don't have permission to do it. And
Okay.
I tried to git clone it and local pip install and so
Okay.
so there's a GCC compilation issue.
Okay.
So I'm not sure. Maybe you'll have to do one of the system admin installers.
Yeah, I would, Dr. Lou, would that be the advisable step, seeing an IT person for permission? Would that be recommended? Yes.
Yeah.
Let's try that, and if not, we'll find another reasonable solution.
I think I'm getting the same thing.
Okay, so that's 2. And you, Dr. Wan, you want them in Max 2, correct? Not Max 1? You want them in Max 2?
Max 1, I don't think a Max 1.4 doesn't have a broader call.
I don't think so either. I didn't see that in the manual. So let me talk to our IT guy, and I'll get some information back. But please talk to your IT guys as well.
I may have a suggestion for that.
Okay, great.
It's just for installing, we started with Python
Yes.
space -m
Yes.
space pip, and then we follow the command
So it'd be Python -space -m
-m
space pip
pip, and then
install Max 2.
Yes, exactly. That might help.
Stacy, try that, would you?
Can you repeat that? Sorry.
Python
Okay.
space -m
Okay.
space pip install Max 2. Nope, I apologize. Pip space install Max 2, and make sure Max is capital. Travis, give it a shot.
It gives the permissioner stuff. So yeah, it gives it's a OS error. We don't have access to the site packages directly.
Okay.
The student.
Okay. Talk to your sysadmin and see if you can get your IT guy and see if you can get it. If not, we'll talk amongst ourselves and see what we can solve for you as well. So we'll get through this part. This is going to be the part that isn't fun. The rest of it will be a lot of fun, I promise you. because this is a great little pipeline. It's fantastic. Bowtie 2 is wonderful. SAM tools is straightforward to convert a SAM to BAM. And Max is a really efficient program for calling peaks, okay? Any questions about any of this? And I really mean this. Please come to my office, email me, call me. I'm more than happy to help you get through this because this is a very, very, very important module. You're going to see a lot more of this happening, okay? I thank you guys very much. If there are no questions, Dr. Wan, do you have anything else for them today? No? Okay, all right.
If you have any questions,
Yes, fifth floor, my office is 5025. Please feel free to come see me. I'm here to support you all the way. So please come. Have a great weekend, and we'll see you next week. Remember, the Tuesday, you have the RNA-seq assignment due. This homework is going to be December 4th. Is that a reasonable date?
we actually, and I don't think you have a class next week. Maybe the week after next week.
Fair enough? Okay. All right, guys. Have a great weekend.
Yes.
We will miss you. You probably won't miss us, but we will miss you. All right. Have a wonderful weekend, guys. Thank you so much.
Thank you.
I hope I didn't move too fast. I hope they understood what I was doing.